Hey guys, it is Queen Kessous here to teach you some laws of exponents. Let's start with negative exponents. I'm going to go fast, so feel free to pause at any point if you need to. So remember that when you have a negative exponent, it becomes a fraction. And I'll give you a quick recap on why that is. Remember that if you have 3 squared, 3 to the first, 3 to the 0, okay, 3 squared is 9. 3 to the first is 3. So as I'm going this direction, I am dividing by the base number every time. So 3 divided by 3 gives me 1. 1 divided by 3 gives me 1/3. So the minute that I get into the negative exponents, it is a division problem, and it will always be a fraction. So 5 to the negative 2 power is going to be equal to 1 over 5 squared. That can be simplified to 1 over 25. Here we have the same bases and we are multiplying. So we learned that we can add the exponents when the bases are the same. So this would be the same as 3 to the negative 5 plus 2. That would equal to 3 to the negative third. Again, I have a negative exponent. So that is going to become 1 over 3 to the third, or 1 over 27, because 3 times 3 times 3. So those are the same thing. Let's keep going. So now we're going to go to multiplying. When we are multiplying, the first step is you always look for coefficients. Multiply those coefficients. 2 times 7. Okay, those are super important. 2 times 7. That will give you 14. And now, if the base is the same, you add the exponent. So I'm just going to show what that looks like. The x has the 3 and the 2, so I'm adding those. The y has the 5 and the 10, so I'm adding those. Because you would have 3 x's here, 2 more here, that's 5 altogether. X to the 5th. You have 5 x's here, 10 more here, that's 15 x's or y's being multiplied. That's how you simplify when you are multiplying. Next thing we are going to do is power outside parentheses. So the first way is whatever is inside, you write it this many times because you're multiplying it that many times. So it's 4 to the 5th, and you write it 4 times. Then you use what we just learned, and you just add those exponents. So we already said if the base is the same, I can add the exponents, and that would become 4 to the 20th power. The shortcut is, if you're adding the same thing over and over, that's just like multiplying. So really, you can distribute. This is what you have to be careful of. Remember that the 5 would be written 3 times. So it would be 5 times 5 times 5, which means that when I distribute this exponent, it has to go to every single thing, including the coefficient. So everything is going to get it. So it's going to be 5 to the 3rd power. X to the 6 times 3 is 18. Y to the 2 times 3 is 6. And Z, if there's no number there, there is an invisible 1 because you have 1Z right there. So 1 times 3 would be 3. Then I can simplify 5 to the 3rd power. 5 times 5 is 25 times 5 is 125. And this would become 125, x to the 18th, y to the 6th, z to the 3rd. So the next one, just like multiplying, we start with the coefficients. Here I'm dividing them, but I want to really just think about simplifying. So what number goes into 16 and also into 24? I can divide those both by 8. Divide by 8. So 16 divided by 8 is 2, and 24 divided by 8 is 3. Now I want to think about the exponents. So you would have 7 x's on top, 6 on the bottom, so 6 of them would cancel, right? Leaving you with just 1 x on top. Really what you're doing is subtracting the exponents. So the shortcut is, when the base is the same, you subtract those exponents. And so this would be 7 minus 1, 9 minus 6 is 1. So you have x to the first, or just x left on top. If there's no number there, you put a 1 in. You have 2 y's on top, 1 on the bottom. 1 would cancel, leaving you with 1 y on top. Okay? 2 minus 1 is 1. Let's do another one, similar. So there's no coefficient in front on the bottom for me to simplify with. So really, I just bring down the 8 on top. Now I look at the x's, and it's x squared on top, x to the 7th. If I subtract that, I would get x to the negative 5th. But we learned what happens when you have a negative exponent. It goes to the bottom of a fraction. Okay, and the 8 would stay on top. Y to the first minus 6, 1 minus 6 is negative 5. So it would be y to the 5th, because that would have a negative exponent as well. So when you have a negative exponent, it's going to move to the bottom of the fraction. Okay, it's going to move to the other side of the fraction. Because x to the negative 5th is the same as 1 over x to the 5th power. Okay. So that's a really important thing, is that if you're subtracting and you get a negative. Another way to think about it, if you had 2 x's on top and 7 on the bottom, when they cancel out, where are the x's that are left? There was more here, so they'd be on the bottom. That makes sense. Okay? So the first thing is, what does a square root mean, right? This is what we've always called a square root, but we've never really thought about that word square. So what it really means is that there's a number squared that equals 16, right? So what number times itself 2 times equals to 16? And the answer is 4, right? We know that. We know that 4 times 4 twice equals 16. Or 4 squared equals 16, right? That's the key here. Squared, square root. But wait, there's no number there. There's an invisible 2. So this is really important. If you don't see a number there, there's an invisible 2. Invisible 2. Okay, so if there's no number, you draw a 2 in. Just like if there's no number on an exponent, there's a 1 right there. We know that. So what does the third root of 8 mean? This would be called third root or cube root, right? Because we know cubed. And so what it really means is what number times itself 3 times equals to 8. So you take a second with your calculator. What is that number? 2. 2 times 2 times 2. Or 2 to the third power. Okay? The exponent is the same as the root. So these are like opposites. Exponent and roots are opposites of each other. So this cube root of 8 is equal to 2 because 2 to the third is equal to 8. Okay? The last one, or another one we'll look at here, is the cube root of 125. So what number times itself 3 times equals 125? Use your calculator for a second, and you'll find out that it's 5. 5 times 5 times 5.
Or 5 to the third power. So the cube root of 125 equals 5 because 5 cubed equals 125. So they're opposites of each other. So what does this mean with higher roots? Same exact concept. Fourth root means what number 4 times? So if you multiply the same number 4 times, is going to equal 81. Well, just try a couple numbers and you're going to see it's 3. And then if you think about it, that kind of makes sense. Because 3 times 3 is 9, 3 times 3 is 9, and 9 times 9 is 81. Okay, that works. So 3 to the 4th equals 81, so the 4th root of 81 equals 3. So you would just write 3 in as your answer. 5th root of 32, what does that mean? Well, what number 5 times? 3, 4, 5. Well, it's got to be a small number, right? So you try a couple things and you'll see 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And so the 5th root of 32 is equal to 2, because 2 to the 5th power equals 32. You can also just do that in your calculator. Try 3 to the 5th power, 2 to the 5th power, 6 to the 5th power. See what works.
So this bottom number, the bottom number is the root index. Okay? The bottom of the fraction, when you have a fractional exponent, it becomes a root, a radical. So a fractional exponent becomes a radical. A radical really just means that you have a fraction as an exponent. So So you've probably never seen fractional exponents before. This is new. You're rewriting it as a root. So the top number is the exponent. That doesn't change. So like x to the a power is still x to the a power. But this bottom number is the key part. This right here is the root. Okay? So if the bottom was 2, it's a square root. If the bottom is 3, it's a cube root. So let's see what this looks like in actual practice. So if we have m to the 2/3, it's going to become a root because it's a fraction. So fractional exponent means that it's going to be a radical. So I rewrite it as a radical. The bottom number is going to be my root. So that's going to be a 3 out here. And then m squared, because the top number is my exponent. Okay, you may be like, why would I need to rewrite it like this? Well, being able to move back and forth can help us a lot, and let's see some examples of how it can help us. So here, this is a root, which means it becomes a fractional exponent. Okay, the exponent stays on top, so the 4 is the exponent. The root, 5, goes on bottom. That's how you rewrite it.